Welcome to this tutorial about a major enhancement introduced in Shear Wall Designer version 5. In this case, the option to design masonry shear walls as per the 2022 TMS 602 Masonry Code. This option is available under Design Code. Notice how when selected, the sketch of the wall automatically changes to masonry. It's important to point out that this latest code presents various improvements and changes that make strength design of masonry walls in general more efficient than previous codes and than allowable stress design. Wall length input is automatically validated to ensure it adheres to modular CMU construction standards. Values must be expressed in increments of half block units. CMU wall thickness can be chosen from nominal thickness of 6 to 16 inches. Notice how the wall sketch is automatically updated based on selections. Wall height is used in certain formulas for wall capacity. Grout spacing can be selected from fully grouted all the way to 120 inches if required. In this case, let's select 16 inches. The program will also prompt an error message if the spacing chosen doesn't fit between end bars. The size of bars in grouted cells are called web bars in the program, which are independent from end bars. End bars are the ones that provide efficiency for strong axis bending and are located at the ends of the wall. In this case, we will select only one end bar. These are also usually of larger diameter when compared to web bars, and in this case we will use a number 9 bar. We will change the masonry compressive strength to 3 KSI and leave all other variables as default. And the option to use bars in compression will be unchecked. We will review this option later in the video. Let's now modify our load demands by using define loads. As usual, axial force, moments in both axes, and shear demand in the strong axis can be specified, and more combinations can be added or deleted. Under design options, we have also added relevant design variables to the code. In this form, the user can also choose the standard rebar set to be used at locations where rebars are specified. These can either be US, Canadian, or international. The properties of the bars can be reviewed using the Define section Properties Rebar Properties menu. Here we have tabulated the diameter and area for each bar available per rebar set. Under the same menu, the masonry properties can be reviewed. This includes tabulated values based on CMU nominal thickness and including area and equivalent thickness based on different grout spacing. These values are obtained from relevant technical guides as noted at the bottom of the form. Once all variables have been defined and reviewed, we can proceed with analysis of the wall. In this case, we can notice that the wall works and that the axial and flexure demand is well under the capacity, so we can always optimize to get a more economical design. Shear reinforcement, if required, is also reported. Let's unlock and reduce the thickness of the wall to standard 8-inch CMU, and also let's reduce the compressive strength of masonry to 2.5 KSI. After running analysis, we noticed that we do get more efficient design as expected since the demand capacity ratio has increased. After running analysis, we noticed that we do get more efficient design as expected since the demand capacity ratio has increased. Now we can save our model and review the reports available. First, we can check the summary report. Here we show all relevant sketches of the wall and interaction diagram. The user can also add company information. And in this version, we have also added an additional report variable, which is slenderness ratio in the weak and strong axis. This has been done for all codes. Next, we can review the detailed report for shear design calculations. In this report, we list all the calculations and equations, including relevant sections of the code, so that the engineer can verify and review variables and equations used. The program also has a very important feature that allows the use of rebar in compression. For masonry walls, it was customary to neglect bars in compression due to restrictions on the code for bar confinement. This has changed in the latest code, which is more lenient in this regard, so the user can decide to use bars in compression to increase capacity. We can easily verify how by using bars and compression, the capacity of the wall increases as expected. This concludes this tutorial. For any questions or comments, please do not hesitate to contact us and to download a trial version of the program.